Hello friends, in this lecture I will explain what is the actual mean of generator set in a vector space. When we say a vector is a subset generates V. So let V over F be the vector space over field F, a subset. Yes, of V. Yes, we write element x1, x2, xn of V is called generator set if each element of V can be written as linear combination of elements of S. Means when we say S generates V, it is denoted by V generate by S or spanning set. So when we say a set of vector S generates V, it's very simple. If every element of V can be written as linear combination of elements of S, means whatever element you will choose in V, we can write as a linear combination of element of S. This is the definition. Now how we prove this one? So it's so much easy. All same like linearly dependent and independent set, choose as many scalars as given vectors. So suppose n vectors given, so choose n vectors. So that is for every x belongs to V, there exists alpha 1, alpha 2, alpha n belongs to F, such that x we can write alpha 1 x1, alpha 2 x2 plus alpha n xn. So same type. Suppose n vectors given, so choose n scalars alpha 1, alpha 2, alpha n. And write its linear combination, means alpha 1 x1, alpha 2 x2, alpha n xn. Right hand side in place of 0 0 0, as we did in linearly dependent and independent, write the vector element, any arbitrary element. Suppose we have r cube, r3. So arbitrary element means x, y, z. And then find out values of alpha 1, alpha 2, alpha 3. If we are able to find the values of alpha 1, alpha 2, alpha 3, then in terms of x, y, z, then definitely S generates V, otherwise not. For example, consider R cube over R. Let S is same 1 0 0 0 1 0 0 0 1. Then R cube generated by S. How we prove? It's easy. Let x, y, z belongs to R cube such that x, y, z is equal to what? Linear combination alpha 1 1 0 0 plus alpha 2 0 1 0 plus alpha 3 0 0 1. So what is it? We get from here x, y, z is equal to alpha 1 comma alpha 2 comma alpha 3. So it means alpha 1 is x, alpha 2 is y, alpha 3 is equal to z. We got the values of alpha 1, alpha 2, alpha 3. It means S generates V. How to check? You can check easily. This is equation number 1. So from 1 what we have x, y, z. We can write as x1, 0, 0 plus y, 0, 1, 0 plus z, 0, 0, 1. So suppose just we put it alpha 1, alpha 2, alpha 3 values here. Suppose you want to write 1 minus 2, 3. So what do you do? Just x, y, z values we have, just put this side. So 1, 1, 0, 0 plus minus 2 into 0, 1, 0 plus 3 into 0, 0, 1. So right inside, if you multiply and add, you will get this value only. So easily we can write any element of V in linear combination of 1, 0, 0, 0, 1, 0, 0, 0, 1. It means V generated by S. So hopefully you understand what is the meaning of generator set. Now I will tell you a very important topic which is called basis. Basis for a vector space. V over F is a vector space over field F. A subset S of V is called basis for V if first S is linearly independent and second V generated by S. That's all. If we have to prove S forms basis for V, then only two conditions you have to check. First, S is linearly independent and second V generated by S. And you know both how we check. For example, as we take 1, 0, 0, 0, 1, 0, 0, 0, 1 forms basis for R over R. Correct? Because already we know this S is linearly independent as well as S generates RQ, means S generates V. That's why S forms basis. So easily you can check. One x square x cube forms basis for R2, PQ over R. Set of all polynomials of degree at most 3 over real number. So easily you can check. This also forms basis of RQ. Similarly, to check any basis, just check it is linearly independent or not, and second, F generates V or not. How we check generator, you know very well. How we check it linear dependent or independent, you know very well. So easily you can check it forms basis or not. In next lecture, I will explain you about the dimension of vector. So dimension of a vector space. What is the meaning of dimension of vector space? The dimension of a vector space is number of elements in a basis of G. See, What is the dimension of vector space? The number of element in a basis of V. So just we check now. S 1 0 0 0 1 0 0 0 1 from basis for R2 over. This implies what is the dimension of R2? 3. Because how many elements are in the basis? 1, 2, 3. So now question is a vector space is having more than one basis. Possible? Yes. There are more than one basis possible. But number of elements in a basis are always fixed, unique. So any basis of R cube having how many elements? 3 only. If S is 1 x square x cube forms basis for P3. What is the dimension of P3? 1, 2, 3, 4. As 1 x square forms basis for P2. Degree 2 column. What is the dimension of P2? 3 elements are there. So in fact, easily you can tell the number. What is the dimension of vector space? Just find out any basis for that vector space and check how many elements are there. The number of elements is the basis of vector space. The dimension of vector space. Now some properties are there for vector space dimensions. What are the properties? First, if W is a subset of V, then dimension of W is less than equal to dimension of V. Second, if W1 and W2 are subspace of V, then dimension of W1 plus W2 is dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. We know that if W and W2 are subspace of V, then W1 intersection W2 is also a subspace of V, as well as linear sum W1 plus W2 is also forms a subspace of for V. And what is the dimension? Dimension of W1 plus W2 is W by this way. So easily you can. So hope you understand this. In next lecture I will explain the properties for linearly dependent, independent basis and other things, and about generator cell. What are the properties it holds? So thank you, and please subscribe the channel